The source transformation basically helps in reducing the circuit to solve it very easily. The basic source transformation happens between a voltage source and a current source. Suppose if we have a circuit in which, or we have a section of a circuit in which there is a resistance in series with a voltage source V, we can replace or we can transform this into a current source by keeping a current source in parallel with a resistor. The same terminal AB is as such preserved, but the circuit undergoes a change, and we have now the resistance in parallel, and the current source will have a value of current I, which is basically given by the voltage that we have seen here divided by the resistance that we have seen here. So we can transform a voltage in series with a resistance to a current source in parallel with a resistance. The same thing can be applied vice versa. For example, if we are having in between terminals A and B a current source whose value is I and resistance R, then we can transform that into a voltage source in series with a resistance where the value of resistance remains the same, R. The voltage is basically the current I into the resistance R. So it is I into R. That is going to be the voltage. Please take care that the direction of current and the polarity you are maintaining. As you can see here, the direction is from down to up, so the polarity is plus minus. This can even happen for the case of AC circuit where we are having, instead of resistance, we are having an impedance Z, which will have some real part and some imaginary part in series with a voltage source, which may be a voltage AC voltage source. We can transform that into a current source in parallel with the impedance, the same impedance Z between the terminals AB that we have in the first circuit, and the value of current I will be basically given by V by Z. Let's look at a problem based on this. So here we are having a circuit and we are being asked to replace the circuit between A and B with a voltage source in series with a single resistor. First, we can draw this circuit in such a way that we understand the circuit much easily. So the 3 amperes current source is there, and then we have a parallel resistance of 30 ohm, which I am straightening it out because it is much easier for us to understand now. Then we have a parallel resistance of 50 ohms followed by a 5 ohm and a voltage source of 20 volt, and then we are having a 6 ohm resistor between terminals AB. Now the same thing can be transformed if I am trying to transform this section, which is having a voltage source in series with a resistance. So the initial part remains the same. So we are having a 3 amps current source parallel to which we have a 30 ohm resistor parallel to which we have a 50 ohm resistor. And now this series voltage with resistance can be converted into a current source in parallel with a resistance. The resistance value remains the same, which is 5 ohms, and the value of current is now 20 divided by 5, which will be 4 amperes. So it is 4 amperes current source, and then finally we have the 6 ohm resistor. Now if you look at this particular circuit, we can see that resistance 30 ohm, 50 ohm, 5 ohm, 6 ohm are all in parallel. Similarly, 3 ampere and 4 ampere are also in parallel, and we know that parallel current sources can be added up together. So we will have a single current source which is 3 amperes parallel with 4 amperes, which will give us 7 amperes current source, followed by a single resistance, because that single resistance will have a value which is 30 parallel with 50 parallel with 5 parallel with 6, and we all know how to do it in calculator. It is 30 inverse plus 50 inverse plus 5 inverse plus 6 inverse, the whole inverse, and that gives us an answer which is coming in terms of ohms. We'll get it in terms of ohms as 2.38 ohms. So now we are having a 7 ampere current source in parallel with a resistance having a value of 2.38. This can be transformed again into a single resistance, which is the same 2.38 ohms, in series with a voltage source, and the voltage source will be the current 7 into the voltage will be 7 into 2.38 ohms, which will give me an answer of 16.67 volt. So here we have the answer, that we are having a circuit with a voltage source in series with a single resistance. Thus, source transformation is basically used to reduce the complexity of a circuit to solve the circuit much more easily.